exponential functions, so they're all essentially the same. We're just trying out, we're expanding on them each time. All right, so let's take the next one. So number 2, quantity changes exponentially over time. So if it says changes exponentially, now I know it's an exponential function. Initially, the quantity is 87. What does that tell me?
C equals 87.
Yep. That means that C equals 87. Perfect. After 6 years, the quantity is 14. So now, this goes together. That means I have another point. What's my other point? 6, 14. Everybody understanding that? Does everyone see where Fox got that? After 6 years, the quantity is 14. 6, after 6 years, you have 14, 14. Okay, good. So, here I have, again, I have it start my function, y equals c times a to the x. I know that my c is 87, so now I can update that. Y equals 87 times a to the x. So now I'm going to plug in (6, 14). I'm going to plug in 14 in for y and 6 in for x, and I'll end up getting 14 equals 87 times a to the 6. Oh, yeah, I did that right. Okay, panic. 6. Just got 14 here. All right, so I'm just going to substitute in those numbers there. All right, so then I have, this is a little bit harder. 14 equals 87 times a to the 6th. So here, this is a tougher one. You're going to have to use your calculators on this one. So first off, I need to get a to the 6th by itself. How do you get a to the 6th by itself? Divide both sides by 87. So let me draw my little line for success down the middle. Divide both sides by 87. And then I will have, let me do this, 14 divided by 87. 0.1609 equals a to the 6th. Now, I need to find a. So I'm going to raise it to the 1/6 power. I need to get a to the 1 or 6th root it. Does anyone feel better about 6th rooting it, or do you feel better about raising it to the 1/6 power? They're the same thing.
6 root what though? A?
Okay, so I'm going to raise this whole side to the 1/6 power. Because remember, power to power we multiply, which means I need to raise this side to the 1/6 power. This is an important step. Are people following me on this or not?
No.
Okay.
Where'd you get the 1/6?
Because it's a to the 6th. What times 6 gives me 1?
Times 6 gives me
6 times 1/6 gives me 1.
1. Oh, okay.
That's why I need to 6th root it. If it was a squared, I would square root it. Does everyone understand what I'm saying?
Oh, you square it. Oh.
That I would raise both sides to the 1/2 power. But if it's a to the 3rd power, then I'd raise both sides to the 1/3 power. Does that sort of make sense? I need this to be 1. So here I have a to the 6th. I need to raise both sides to the 1/6 power to get rid of the 6. So then I only have a on this side, a to the 1. It undoes the 6th power thing.
Okay. Or you could square root both sides, right?
No, if I square root it, I'd have a to the 3rd.
Oh,
Then I'd have to cube root it.
okay. Oh, okay, so whoops,
So if you do this, you take care of it in one fell swoop.
okay.
So I'm going to raise 0.10. Yeah, I need to raise it. So let's do this.
0.73.
How would you do that?
So I have 0.1609, and I'm going to raise it to the 1/6 power. All right, so there's 2 ways of doing this. You can either find 1/6 to start off with, and I'm kind of lazy, so I'm going to do that one. 1 divided by 6. I get 0.166666666. Everybody good? Yes? No?
What if you just put it on parentheses after the?
Or you could do that. So 0.16, I don't like to mess with that, so I just am going to do like this, raise to the 0.166666667, maybe at the end. And I'll get that. Now you could do 0.101609, which I think is what Fox does, and she raises it to the, in parentheses, 1 divided by 6, like that. You can also do that. Either one of those works. And either way, you're going to get the same number. Everybody do it now, on your phone, or on your whatever, because if you don't practice it now in class, there is 0 chance you're going to do this on your own without being in class. So everyone try doing it right now. You might have the A to B thing, like the X to the Y. Same with the X to the Y thing.
Okay.
I don't have that either. Oh, I do have this. Okay, so then here I would do 0.1609 raised to the parentheses, 1 divided by 6,
Yeah, that's it.
like that.
Yeah.
I'm trying to practice with this thing, because I screwed up last test.
Good?
Trying to deal with that.
All right. Good? So we have our answer. 0.7375. All right, so to 3 decimal places. Are you kidding me? All right, well that's annoying. To 3 decimal places, it would be to 737. Because there was a 4 next, so that rounds down to 737. So this is y equals, what's my C? 87. Times what's my, parentheses, what's my A? Ryan, what's my A?
0.737.
To the X. So you folks are getting it, you're just being very quiet about it. It's only the 3 people who sit in the front row who talk. Natalia and you two, that's it. Okay.
737 to the X?
Yeah. Does this represent growth or decay? Decay. This number is less than 1. And you'll notice after 6 years it went down. It started at 87, now we only have 14. So it's 2 ways of telling, right? We've decreased in the amount we have.
Except it doesn't ask for you to figure out the equation and figure out if it's a decay simply by
Yes. Simply by,
putting the initial and then how the quantity has changed.
yeah, and how the quantities change. Great, that's a good way of putting it. Excellent way of putting it. All right, so you folks, try one. Here, first let's find the 2 points. So everyone, here's my internet use in Western Europe has grown rapidly. Here's my table. X equals 0 corresponds to the year 2000. Y equals 2 corresponds to the year 2000. So here's my table here.
2002.
So everybody write down the 2 points we have from this. There's 2 points you have from this, write them down. X comma Y. Find your 2 points. So what's 1 point I have?
0, 52.
0 comma 52. Initially, year 0, my Y was 52. What's the other point I have?
2 comma 85.
Great, 2 comma 85. Perfect. So you folks work on that one. You're using Y equals C times A to the X. X is your time. So it's usually going to be weeks, months, days, minutes, something like that. Y equals C times A to the X. Your initial amount, your C, is when X is 0, a time 0, when you start with. Right? When your year is 0, when your minutes is 0, whatever, when your time is 0. When X is 0, C is your initial amount. Your Y is your initial amount. So when X is 0, what's Y? That's your C. So all you're doing is finding what C is, your initial amount, and then use the other point to find what A is. All you're trying to do is find C. After you find C from your initial amount, find A. What's our initial amount? What's our C in this case?
52.
52. 0 comma 52. So C is 52. Plug that into your formula. That's your C. Now you need to find A by plugging in the other point you have. You can go over that. Okay, so we know that our C is 52. So now we have Y equals 52 times A to the X. So now all we need to do is figure out what A is. So I'm going to use this other point, and I'm going to substitute in 2 in for X, 85 in for Y, to find out what my A is. So I'll have 85
Yeah, there was.
equals 52 times A to the second,
It's mine.
because that's the 85 on the 2.
Different.
I need to solve for A. How do I solve for A?
Please first divide by 52.
Yeah, first divide by 52. And I think David, what'd you get for that?
Hang on.
1.63, I think, or something like that,
Yes.
equals A squared. Now, how do I undo A squared? What's the opposite of squaring something? Square rooting it. So we're going to square root both sides.
Oh, so you don't have to do the to 1/2?
Yeah, to the 1/2, same thing. Square rooting something is raising to the 1/2.
Just
Oh,
sometimes it could be harder to square root than do the exponent on the column.
Yeah, so maybe we should just, well, so it's the same thing as doing, so maybe I better write this down. 1.63 to the 1/2, that's square rooting, equals A to the second to the 1/2. That's the square rooting part. So then we end up with 1.277, I think, is that what you got, David?
Yes.
Oh, I got
equals
276.
If you round it to one more, oh, it depends on.
I did 1.635 at the top.
Okay, yeah. So I think we should end up with,
1.279.
okay, well, you should have something right in that range. So maybe we'll say, we'll call it 1.28. How's that sound? Is everybody happy with that? So then our final answer, so now we have our A, we have our C. So we have y equals c, which is 52, times a, 1.28 to the x. Done. Is this growth or decay?
Is
Growth, because my factor is larger than 1. Okay, so now we're going to approximate number of internet users in 2007. In 2007,
2004.
4.
yeah, sorry, 2004. So what's x? X is what? 4. How about in 2016? X is what?
16.
Okay, great. So let's find it. For 2004, I'm going to plug it in. Find that. 1.28 to the 4th times 52.
139.59.
I'm going to double check and see if I got the same thing you got. Enter. Times 52. 139.229 is what you said?
I got 139.586.
0.58. Oh, 0.58, yeah.
137 for some reason.
139.6.
39, yeah, 139.6.
Okay. So that should be, this is million, right?
But the equation would vary depending on when and how you rounded it. And
Right, but that should give us, if we round up one decimal, it should be pretty close. And then let's do the next one. 1.28 raised to the what power?
16.
16 times 52. This should give me 2,700 million users. So that ends up being 2,700 million, which is 2,700 million. That many users. Now, the estimated population in 2016 was only 191 million. So you can't have that many million users if you only have that many people. Does that make sense?
Model escalates too fast.
Exactly. Nice. I love that. Model escalates too fast. Perfect. So it wasn't realistic, but we did kind of find the model. Okay, so we're going to do, we're going to talk to you folks a little bit about this. So as we learned in the the first worksheet, the base is 100%. That's what we start with. So if your base is 100%, then you have no growth, no decay. It just stays the same. Or you keep 100% of what you had before. If you decay, or sorry, if you grow, you take your 100% and you add whatever percent you're growing. I remember I was calling this the rate of increase. If you add those up, they give you the growth factor. If you're going to decrease, decay, you take 100% and you subtract the rate that you're losing, the rate that you're decreasing, and I call the amount that you add or subtract your rate. So this is your rate, and then when you put them together, that's your factor. So you always start with 1, and then or 100%, and you either subtract a percent from that, or you add a percent to that to get your factor. So it's your initial amount times your decay factor or times your growth factor to the x power. Is that sort of making sense for folks? I'll show you one quick example. So for here, it increases by 130% per day. So this is how much I'm increasing. So I have 100%. I'm going to add 130%. So then I'll have 260%. Everybody with me on that part?
Maybe 230?
On the second.
Oh, sorry. It would be 230. My bad.
That's
My initial amount was 700. That's my C. So this is 2.3 in decimal. 230% is 2.3. So then I would have y equals 700 times 2.3 to the x. Does that make sense for folks? Where those came from? That's my initial amount. I increase by 130%. That's my rate of increase. So I have 100%. I increase 130%, add 230%, which is 2.3. That's my growth factor. My initial amount, C, times my growth factor to the x power. Done. Okay, we'll finish this one up next class. But I want to at least give you an initial part about that. Have a great weekend, and we will see you all